Hello everyone, this is a quick start video, a fast introduction to using a smarter display from Proculus. Here with me, I have the classic components that customers commonly use. I have a smart display, a cable for the display, a PAB31 adapter board, and a PAB02 board. Now I will briefly introduce these components. The smart display comes in several models, meaning there are different display sizes. The model I am holding here is the 7-inch version, and I will quickly show the main peripherals of the display. Keep in mind that the other display models also have these same peripherals. Starting with communication, the display has 3 ports. These 3 connectors are port 0, port 1, and port 2. Each connector has printed pin labels showing the exposed signals. These signals are available both on the connector, where you can use the cable, and also on the pins beside it, where you can easily solder pin headers or wires directly. In these connectors, you have the power pins VIN and GND, positive and negative, and the communication pins RX and TX. Across the entire line of Proculus Smart Displays, the electrical communication level on the connector is TE-TL. There are optional converter boards that allow communication in RS-232 or RS-485 if needed. These accessories let you choose the electrical level you prefer. Another important peripheral is the RTC, the internal real-time clock. The display has a battery holder, and this battery powers only the RTC, keeping the clock running even when the display is turned off. There is also a connector for attaching an external battery, if desired. The display includes a micro USB connector, but this port is reserved and should not be used. Another key peripheral is the SD card slot. This is where you insert your SD card containing the project you want to transfer to the display. The smart display also includes a reset button. Pressing this button restarts the display. Now about the accessories. The PAB31 board is a connector adapter board. On one side, you can plug the cable into the standard display connector, and the same signals are exposed on 2 additional connectors, where you can use a flat cable or ribbon cable. This board also exposes the display signals through pin headers, allowing you to solder wires or plug it into a breadboard. So if you want to avoid soldering directly on the display board, or if you want to prototype easily, this board is very useful. The PAB02 board is mainly used for serial communication between the display and a computer. This is typically done using the UnicView terminal software, our communication terminal. It is extremely useful for serial testing and debugging. Another important function of the PAB02 board is that it makes powering the display much easier because it includes a jack connector. You can plug an external power supply directly into it. The board has 2 jumpers. One jumper selects the communication mode, switching between TTL and RS-232. The other jumper selects the power mode to power the display using an external power supply. The power jumper must be set to the jack position. Here I am connecting a 12-volt supply, and the display powers up immediately. So to turn on your display, you can use this board if you have it, or you can simply power the VIN and GND pins directly by soldering wires or using the method you prefer. Now let's demonstrate how to transfer a project to the display. The display is programmed using UnicView Studio. This is the software used to create the graphical interface project that you load into the display. You can download UnicView Studio from the official Proculus website. No license is required, just download, install, and run. With the software installed, I will now transfer an example project. To do that, I will download a ready-made project from our demos page on the website. There you can open a demo project and access the official GitHub repository to download all necessary files. After opening the project in the software, make sure the project is configured for the correct resolution of your display. Here, the project is already set to the correct resolution, which is 1024 by 600 pixels. If you are unsure about your display's resolution, you can confirm it in the product datasheet available on our website. If you need the project in a different resolution, you can use the export feature to convert the project to another display model. With the correct project loaded, insert your SD card into your computer and select the device from the list. This list shows all flash memory devices detected by Windows. Then choose the project transfer method. The available methods are internal memory and external media. In internal memory, the project is written into the display's internal storage. After the transfer is complete, you can remove the SD card and the project will run directly from the display's internal memory. In external media, the project runs directly from the SD card This is very useful during development because after making changes in the project, you simply export it again, plug in the SD card, power the display, and the updated interface runs instantly without any transfer time. This greatly accelerates development. With the device and method selected, compile your project, then click the export button. The software will generate the project files on your SD card. Here, since I selected internal memory, I will place the SD card in the powered-off display, turn it on, and the transfer will begin. When the progress reaches 100% as indicated on the screen, I remove the SD card and reset the display. The project is now successfully loaded and running. Now, a brief introduction to serial communication with the display. The display uses its own communication protocol called the Lumen Protocol. It sends and receives data following this protocol through the UART pins, RX and TX. To make this communication easier, we provide the Lumen Protocol Library, which can also be downloaded from our website. The library is written in pure C, so it is compatible with virtually any microcontroller and any C compiler. We offer some example codes, mainly written for Arduino for convenience, but the library works with any controller, such as ESP, STM32, PIC, ARM, Raspberry, and many others. Inside the library, you will find an examples folder, and our demo projects on the website also include the full example code. With this short introduction, you have seen the main peripherals of a Proculus Smart Display, how to download UnicView Studio and the Lumen Protocol Library, how to power your display, how to transfer a project, and how serial communication works. These are the essential first steps for getting started with Proculus Smart Displays. For more detailed information and to continue learning, you can watch our full training series on YouTube, where we show in depth how each part of the software works. Thank you for watching.